Hi everyone, here's Simone from Unwrapping Studio. Welcome into this new touch design tutorial. This is the first one of this new year, so happy new year to all of you. I hope you had great time and hope you're ready for a new exciting year of experiments. This time I would like to reply to some Patreon that were kindly letting me know that my unwrapper was not working in the new version of Touch Designer. This is why the derivative made a little update onto the RenderTOP that, on my opinion, is a bit poor implemented since we have to deal with expected error. So error is an expected behavior. So let's analyze the VIP of this lesson. Is the RenderTOP. And as you can see here, we have no more GLSL1 and GLSL2 page, but we have a page called images. What this page allows us to do is to generate buffers that we can fill with information coming from the render pipeline. So expose data via texture directly by writing a material. An example of it is this unwrapper, the new unwrapper, the new unwrapper. So the updated one that works in the last one. As you can see, I don't need to update, so I'm in the last one possible. And at the time I'm recording this video, so this day here. As you can see, we have an error, but everything is working as expected. I'm creating 3 buffers with this material that are reading those data. The position, the normals, and the UV. And I'm using image store, that is the new capability. That actually it's a function that you can use in GLSL, but in the GLSL material in Touch Designer, you will access those buffers here. Okay. Then I will prove now that this is an expected behavior since it's written in the documentation. We can refer to the RenderTOP operator. Yeah. Then we can go and the documentation of the RenderTOP, check for parameter image page. Okay. And go here, write a GLSL material, because this is what we're going to do. We're going to write our own GLSL material to output data from SOP to top without needing to pass through CHOP. So it's a little bit tricky to say, but this is what we are going to do by using these new things. And here, I will zoom. Currently, when compiling GLSLMat itself, your code will result in an error. So it's in the documentation, the error you see, and you can do nothing about. You have just to say, okay, you have an expected error. Why you have an expected error? Because at the time you are in the stage, you are asking for those images, they're not. But when the material goes to the render, then it's fine. So why just to not take out the error? Strange implementation, but it is like this. Okay, so this is the new unwrapper. The file will be in the link of the file will be in the video description, and it will be free even if it's on my Patreon that I kindly suggest to support. Okay, so yeah, the whole example here will be so even with the new VAT. A capability of the new VAT that I had with this buffer is to have normals here. So yeah, you have a buffer that is reading the normal of the object. So if you want to make, I don't know, append stuff, you can do it. Okay, let's take this, and now we will build as fast as possible without too many explanation, because I did a whole series about it, how to use the unwrapper with the new feature that are the images of the RenderTOP. Okay. Oops. Disconnect. Okay, so we have a SOP. Okay, we will have a render. This render will be linked to our render select, and the render select will read an image output. I already know the name I want to give. This is std-pos, and we will have more than one, and the other one will be read std-norm. Okay. Let's also compile the SOP context as required, so we need an index for all the points. I drop a point SOP. I want to create a custom attribute, call it index, and this is me.input point dot index, and this is an error, so point, yeah, without the s, input point. So yeah, now we have an integer at point, we have an attribute at point level called index, is fine. And yeah, the render, of course, you need a camera to exist, even if we are not using it. Since we are not using a camera, this will be a 1 pixel render, and its nearest pixel and 32-bit. Okay. Why not? So let's actually yeah, let's compile this page, the new one, so std-pos, as I wrote here, std-pos, okay. And then we want another image called std-norm, okay. So now we want those texture to be to contain the amount of points we have here. Okay, we pass this. Yeah, we need so this is, let's call this object. This is the object, and we will now use a feature of the SOP that can communicate with the render without needing of a geometry. So you can just make this. So if you flag it purple, then this will be rendered. Okay, I will prove you pretty fast. See, I have an ad there. I can go more near with the camera. Yeah, I am rendering something here, even if I don't need it. Okay, if you take out the flag, okay, so we are sending this SOP to the render with the flag, and we're good to go. So I go back to my 1 pixel, because I will use these images instead of the color output. So okay, let's set the resolution. The resolution is the square root of the number of these, number of points of containing that SOP. So is object, and then I want to take the num points, and I want to have the square points. Yeah, and then we want to take the square root of this. Mat dot square root. Right. So we are now have a 73 by 73 square texture that should match this. And I noticed that sometimes you're missing points for whatever reason. So this is a waste of pixel, but they will be discarded anyway later on. So just make a +1 here and you're good to go. It's not a really good solution, but it's the fastest I can find. It will never give an error. So everything match. Also here we put a +1. So both texture are now related to the points, but here we have the UV that are not related to the points. After you see what is the problem. Actually, let's make a buffer also for the UV. So this is std UV that takes same stuff here. And you could do this as well by referring to vertices. That maybe make more sense. But since for what I'm used to do, I do not like to share point instead of vertices if I have to work with a geometry, because then I can refer to the single primitive and move it without causing deformation. So you can even break it. You can even break geometry if you wish, without the need of some strange stuff. Okay. Okay, so I create here the buffer. I call it as I want. Yeah, all the buffer needs to be 32, 32, 32. I think we are missing one here, that is std UV. Alright, so we have a render that's rendering 1 pixel. This took half an hour, but is what we actually need, what we need. Okay, so let's now do some trickery with a GLSLMat. Okay, how to, you see there's no geo here, so where do you want to put it? You want to put it as override material. Okay, nice. So we are now ready, finally, to take some information here and write it to these things here. S, Control S to save this beautiful work. Okay, let's open the vertex. And no, we need something in the vertex shader as well. We need a vector called width, because we need to do the trickery with the modulo to create the square. So we need the width, and the width is this. Actually is this. +1, if I'm not mistaken. Let me check. No, so without +1. Without +1. Okay. Okay, this will be our width. Okay, now we have everything we want. So we have the attribute and the width, so we can build the square texture. Let's view this and write it. Okay, we will never have render picking here, so because we have 1 pixel to pick. So what we're going to pick in 1 pixel? Nothing. This is not anymore an example shader, because we become our shader. Let's zoom, so we can read. Okay, new stuff happening here. We have a td_pos function, a td_normal function that will give us back what we want, but this is useful in our case. So this will become a vector. It should become this is yeah, we can use it to fetch things. Yeah, so we will actually, let's be organized. Let's first declare the uniform. So we need a uniform that I connect to the GLSLMat, that is the width, that I want to take it as an integer, so like that. Then we also read something from the subcontext, so you take in, since it's the first stage of the render pipeline, is the vertex shader. You can, with in, you refer to what is before, in our case, the subcontext. So I can now read the index by doing so. And then go here and do not use this, because I want to expose data. Yeah, so actually I can even read this, or to be precise, that's all the things. You should do nothing here. And also, yeah, I mean, now those are doing nothing, but maybe we need it. They are doing nothing. So everything here after is doing nothing, because you just put a 0 as, okay, so, pardon, with the organization. So here this is doing nothing. Skip. we can skip this. Okay. To actually skip it, we can delete it. We don't need it. But maybe we need a GLS position. So let's pass here a back for empty, because this one we need it for sure, and this we can skip. Yeah, super clean. Okay, so here inside of the vertex shader we will not deal with vertices, but we will deal with texture. It is a crazy thing, but you can do it with image store now, if you did the setup correctly. Image store, then you want to store what, where? In the std pose sampler I create, and here I need an IVEC2, and the IVEC2 is made, and this is the trick I described in the first or second GLS unwrapped geometry. So here you take the index and you do modulo the width, and then you take index, yes, and then you take the index again, and this, yeah, you divide it for the width, yes. So by doing this you are creating a square of points that match the expectation you need to. This is what we're going to store. We will not use tdpos, since for some strange reason it's not doing what I asked. If you make p is better. Okay, so now I'm storing the position there, and I'm pretty sure if I then copy this beautiful line, I paste it, I say norm, and I want to store n, and then I want to also store in the UV, the UV can be accessed with this syntax. Actually, can I store a vec3? Let's see. Let's see. Okay. Do we have texture here? No. Okay, so yeah, I need to pass a vec4 to match the expectation of the image stored. So this will be a vec4, and then p has 3 parts, so the last one will be the index. So okay, check index. Yeah, same things for n. So copy this, make an n here, and copy. No, here I will compile it as follow. First 2 parts of the vector are the UV, blue I don't need, and the alpha is the index. Voila. So yeah, now finally we have something in our buffers, and to show you that I'm not mad, we have the point of the head. Look at this, pretty nice. Okay. Okay, then now a little explanation of why are we having some stuff here. So you see, if I now check the UV, this is the UV buffer, you have those points that are every frame trying to interpolate between some position, due to the fact that we are sharing point among a set of vertices. How to avoid this? You have to augment, make more the number of points. And how much you need to make it more? You need to make it more in order to match the number of vertices. So each vertex is a point. So how you are making those vertices, you have no shared point. You can do it with facet, and then you say unique point. By doing so, you dramatically augment the amount of points, but now you have one point per vertex. You can do other stuff. This is a bit more expensive, but in some cases it's useful. So with this facet, I will now bypass it for the usage we need. Okay, so why is this really powerful to me, and why the normal are like that actually? So that's so strange. Aha. They need to be 32-bit float. Pardon, this was not compiled correctly. And yeah, those are the normals. And our normals are always represented 1 to 1 sphere. Yeah, the position of the sphere is like the direction where is the normal from this point. Okay, why is this powerful? Because we'll avoid you the conversion to chop, so you can take any chop here now. Take a torus, for example, torus. Okay, plug the torus here, and you have a torus. You have all the point of the torus. You can do point cloud, or use the VAT as I show in the example, and what I already explained in my series about the unwrapper geometry. Okay, so this is the update. As I said, the project I showed you before will be free for you in my Patreon. You are kindly asked to support my research, and for the Patreon I will update the VAT, since you could actually skip the unwrapper and do everything in one geometry that take care of unwrapping and expose the texture for you. So stay tuned. Thank you for your time, and I wish you all a really good new year full of interesting discovery. Ciao!